Hello everyone, my name is Devarpana Trivedi and I am a student of BSc Honours Data Science and AI program at IIT Guwahati. Today I will be presenting my internship one project titled Development of uh, Railway Incident Monitoring Dashboard with Computer Vision Dataset Preparation. This project focused on building a centralized railway monitoring system with role-based dashboards, dataset integration and computer vision dataset preparation for future surveillance applications. So now, the project overview. Our modern railway system generates a large amount of operational and incident-related data. Managing these records manually becomes difficult, especially when multiple stations and administrative levels are involved. So the main goal of the project was to develop a centralized monitoring dashboard where railway incidents could be tracked, updated, and managed efficiently. Along with the dashboard development, also worked on computer vision dataset preparation using railway surveillance streams for AI-based monitoring system. Objectives. The main objective of this project were first to develop a centralized railway incident monitoring platform. Second, to implement role-based access for different users like ground staffs and administrators like station admin, and journal head. Third, to design a structural relational database for incident and case tracking. And finally, to prepare annotated datasets for future computer vision applications related to railway surveillance. Tool stack. Uh, wha- for tool stack, I have used front-end development, HTML, CSS, JavaScript, and Bootstrap also. And for backend, I have used Flask and Python. My MySQL was used for relational database system, and for computer vision, I have used RoboFlow for annotation and dataset preparation. Now for system architecture, the system follows the client-server architecture. First of all, the front end provides role-based dashboards for users such as ground staff, station admin, and journal heads. The backend layer, developed using Flask APIs, manages authentication and report handling and communication with the database. MySQL stores structured information such as user, um, stations, incidents, and case recordings. Additionally, the computer vision pipeline handles uh, filtering and annotation of railway surveillance frames for future model training. This is the data set. This is how the database looks like. Now for front-end development, this slide shows some of the front-end interfaces developed during the project. The system includes authentication and user onboarding pages with role-based access support. Separate dashboards were customized for different categories of users. Bootstrap was used to create responsive and organized user interfaces for smoother workflow handling. For backend and database, the backend system was developed using Flask and MySQL. Flask APIs were used to manage communication between frontend and database, and the database was migrated from PostgreSQL to MySQL to improve compatibility with the system requirements. The relational schema was designed to manage users, station records, incidents, and case level tracking. Incident incident report management in this slide. This slide demonstrates the incident management workflow. Ground staff users can update train incident statuses and add remarks for the specific reports. Administrative and journal users can monitor pending alerts, generate cases, and view summarized monitoring statistics. This centralized workflow improves tracking and coordination compared to manual processing. Admin and journal dashboard. The station dashboard provides centralized statistics and report management within a station. The journal head dashboard extends monitoring across different multiple stations using station selection and alert management features. This dashboard support hierarchical monitoring and administrative coordination, computer vision dataset preparation. So for this part of the project focused on dataset preparation for future railway surveillance models. Railway video datasets were collected and manually filtered to remove blurry and irrelevant images. Door lock regions were then annotated using bounding boxes and overflow. So this is an image that I have generated using AI because as per the company policy and confidentiality issues, I am bound to not show the real images of the database. So I had to generate an AI image for that. So railway video datasets were collected and manually filtered and removed the blurred irrelevant frames. Then door lock region were then annotated using bounding boxes like given in the uh, image. And then the final structured dataset can later be used for machine learning applications such as automated door lock detection. Now, for uh, for implementation and result, um, the development was successfully deployed and tested across multiple local environments. Stable integration was achieved between the front end and back end. Yeah, it was successfully deployed in AWS server. The dashboard enables structured incident tracking and management workflows. Additionally, high-quality surveillance datasets were prepared successfully for future AI-based railway monitoring applications. Challenges and conclusion. During the project, several challenges were encountered. This included database migration from PostgreSQL to MySQL, deployment-related issues across systems, and filtering noisy surveillance frames during annotation. Overall, the project successfully delivered a role-based relevant incident monitoring dashboard um, integrated with structured database management and computer vision dataset problem. The project provided practical exposure to front-end development, database engineering, deployment, workflows, and surveillance-oriented data preparation. Thank you.